Now conversion between the canonical forms. Okay, so replace summation with pi and replace those j's that appeared in the original form with those that do not. See, let us see an example. F1 of a comma b comma c equals, this is what the expression, and the minterms for this particular expression is m1 plus m2 plus m4 plus m6, and the max terms for this expression is the terms which are not the minterms, those are nothing but your max terms. Okay, so these are the minterms. Apart from these terms, the remaining all other terms are considered as the max terms. Okay, so if any expression is given and if you are asked to find out the minterms and max terms, so this is how we are going to find out the minterms as well as the max terms. Now let us see the standard forms. So up to now we have seen canonical forms, where canonical forms can be of two types, that is canonical sum of products and canonical product of sums. Now standard forms are not similar like the canonical forms. Let us see. Standard forms are like canonical forms, except that not all variables need appear in individual product or sum terms. It means every product term as well as sum term in the canonical form contains all the variables, but whereas in case of standard forms, they may or may not contain all the variables within a sum term or else a product term. So let us see an example with a function f1 of a comma b comma c equals a complement b complement c plus b c complement plus a c complement. So it is a standard form. Why? Because here, if you can see here, a, b, c are the three input variables. In case of canonical form, all these three input variables might or definitely they will appear in each and every term, but whereas in case of standard forms, they may or may not appear in each and every term. Okay, so the same standard product of sums. Okay, conversion of sum of products from standard to canonical form. So what we have to do in order to convert a sum of product in the standard form to the canonical form? Expand non-canonical terms by inserting equivalent of 1 in each missing variable x, that is x plus x complement equals to 1. So remove duplicate minterms. So these are the two things which we have to follow in order to convert standard SOP to canonical SOP. Okay, so what is the first statement? That is, we have to insert equivalent of 1 in each missing variable x. Okay, so let us take an example: a complement b complement c plus bc complement plus ac complement. So the first term includes all the input variables. Now when it comes to the second term, it contains only two variables, that is b and c, but whereas the other variable a is missing. So what we have to do, we have to insert the equivalent of 1 in each missing variable, that is x plus x complement. So x plus x complement is nothing but 1. So here we have to write, in place of x, it is substituted with a. So a plus a complement into b c complement. In the same way here, b plus b complement. Now expand this: a complement b complement c and a b c complement plus a complement b c complement plus a b c complement plus a b complement c complement. Now what is the second statement? Remove duplicate terms, in the sense, if one term, for example, if one term is used many times, then we have to remove that. So here, if you can see here, a b c complement are used twice here, that is more than once. Therefore we have to consider only once regarding this particular term. So it becomes a complement b complement c plus a b c complement plus a complement b c plus a b complement c complement. Okay, so now this is the sum of product terms in canonical form. Okay, now conversion of product of sums from standard to the canonical form. Okay, again here we have to follow two statements or two rules. Expand non-canonical terms by adding 0 in terms of missing variables and using the distributive law. So here in case of sum of products, we have used or we have added 1, but whereas here we have to add 0, that is x into x complement equal to 0. Remove the duplicate terms. So similar to the similar to the conversion of sum of products, but the only difference here is we have to add 0 by using x into x complement. Take an example here. So here the second term is missing with the variable a, and the third term is missing with the variable b. Okay, so expand it now. Dot, write the first expression or write the first term, and then it is added with a complement, and it is added with b complement. Now expand this, and this is what you are going to get. Now we have to remove the duplicate max terms, which are nothing but if any max term is appearing more than once in an expression, that has to be removed, and we have to consider only once. Okay, so here it is appearing more than once, that is 2 times, therefore we have to consider it only for 1 time. Okay, so this is how we are going to convert the standard, that is standard sum of products to canonical sum of products, as well as standard product of sums to canonical product of sums. Okay, in the next session we'll discuss about the logic gates and how to design or how to analyze any kind of electronic circuit with the help of logic gates. Thank you. In the next session we'll discuss about the basic logic gates. Thank you.